I bit my tongue a couple days ago, and it's been hurting ever since, and it's making it really difficult to talk. Well, I think it's why I keep using these weird voices, uh, because somehow it makes it feel better. Also, Haley used a funny voice in class today, and I don't know why, but I really liked it, and I think maybe I'm kind of imitating that a little bit. I don't know, maybe I'm just tired. But let's go. This polynomial has an imaginary solution of 3i. Notice it says imaginary zero, and I said imaginary solution. That's because they're synonyms. They mean the same thing. Two things we need to know. Thing one is the complex conjugate roots theorem. It says that if 3i is a solution, then so is negative 3i. So let's make like let's make solutions. Let's list solutions. What am I even trying to say? Oh my goodness, I'm tired. Boom, 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 boom. Solutions at x equals 3i. And then we're going to have another one at x equals negative 3i. Solutions always occur in conjugate pairs, which means leave the real part as it is and change the sign on the imaginary part. So 3i goes to negative 3i. Well, that's the complex conjugate's root theorem. Since this is a fourth degree polynomial right there, the linear factorization theorem says that I will have two more solutions. So I know I'm going to have another like and x equals something and another x equals something. I need to have four solutions to this as long as I'm allowing complex numbers. So there's that. Another thing the linear factorization theorem says is that if you have a solution, you have a factor. X minus your solution will always be a factor. So I have to have the two factors, x minus 3i and x plus 3i minus negative 3i is what that dude is. And now we multiply, and when you multiply this together, you will get x squared plus 9. What? How'd you do that, Mr. Reed? Well, I did x times x was x squared, and then I didn't do x times 3i is 3xi, because then I would be about to do a negative 3i times x is a minus 3xi, and those cancel, and that's a waste of your time to do that. And I also didn't do like negative 3i times positive 3i is negative 9i squared, because I know that I squared is negative 1. So that's like negative 9 times negative 1, which is like positive 9. So x squared plus 9, that's what x minus 3i, x plus 3i is equivalent to. And what are we going to do? We're going to do some division. Can you do synthetic division? No. And I need to like point this out right here because I keep seeing people miss. Oh my gosh, I just like ranted and raved for like 8 minutes explaining things only to figure out that I hadn't pressed the record button yet. So that was fun. This screen looks a little different than when you left it a moment ago. A moment ago I said solutions at x equals 3i and negative 3i, and I listed them. Notice how I'm writing it. Solutions at x equals 3i and x equals negative 3i and x equals blank and x equals blank. I know there are going to be two more solutions because this is a fourth degree polynomial. The linear factorization theorem states that there will be as many solutions as there are as whatever the degree is. Fourth degree, four solutions. So I know that I'm going to need to be finding two more. Another thing that the linear factorization theorem states is that if you have a solution, you have a linear factor. So since we know that 3i is a solution, x minus 3i has to be a factor. X minus the solution is always a factor. So we have x minus 3. Then we have x minus a negative 3 is x plus 3i. Those are my two factors. What are we going to do with these two factors? We're going to multiply these factors together, and we're going to get x squared plus 9. But Mr. Reed, how did you do that in your head without doing any work? Well, look, x times x is x squared, and it would be a waste of your time to do x times 3i, because x times 3i is just going to be 3xi. And then your next step would be to do negative 3i times x, which would be minus 3xi, and they'd cancel each other out. So you just wasted your life doing that. What about that 9, though? How'd you know that's going to be a plus 9? Well, look, negative 3 times positive 3 is negative 9. I times I is I squared. And again, I squared, you should know by now that that is negative 1. So we got negative 9 times negative 1, which gives us positive 9. Homie, these are conjugates. It's always going to work like that. The imaginary stuff is going to go away. You're going to be left with real things. Boom. Okay. Now, a lot of people at this stage are like, oh, x squared plus 9, it's quadratic. Oh, let's factor that. Let's make it look better. Let's go x minus 3, x plus 3. Dude, you just factor that as if it was a difference of squares, and that says plus. That doesn't say minus. That is a sum of squares, which you cannot factor like a difference of squares. Plus, dude, you started with this factored. That's how you got this polynomial. By trying to factor it again, it's kind of like, ooh, you don't really understand what's going on there. We factored it with complex numbers. If you picture this quadratic, x squared plus 9, it looks like that. It's shifted up 9. It does not have any x-intercepts. When a polynomial doesn't have x-intercepts like that, that's what's giving it imaginary solutions. That's where we started, and we used that idea to get the polynomial x squared plus 9. Ranting and raving. All right, well, what do I do with that x squared plus 9? Because I want to use that. I'm going to get rid of all that other stuff because that was just me being an angry, bitter old man. I'm like, what, 70 years old? Something like that. All right, so x squared plus 9. What do I do with it? Well, I got to do division now, right? I got to take my polynomial, x to the 4th minus 3x cubed plus 11x squared minus 27x plus 18. To take that, and I have to long divide it by x squared plus 9. I have to do long division. You cannot do synthetic division because you are dividing by a quadratic. If you do synthetic division and try to divide by like 3 because you think x minus 3, you're going to get a remainder, you're going to be sad, you're going to be confused, and you're going to waste a lot of time. So you have to do long division with this. All right. Well, x squared goes into x to the 4th how many times? X squared times. X squared is x to the 4th. X squared times 9 is 9x squared. Notice that I write my terms all lined up. You see like an entire column there of x squareds. All right, well, now we subtract. So x to the 4th minus x to the 4th is 0. So we're happy there. Minus 3x cubed doesn't have anything that it's subtracting. So that's going to come down and just still be minus 3x cubed. 11x squared minus 9x squared is plus 2x squared. And let's go ahead and bring these things down. Minus 27x. And ask yourself a question. What do you need to multiply x squared by to get negative 3x cubed? You need to multiply it by negative 3x. Negative 3x times x squared is negative 3x cubed. Negative 3x times 9 is what? Negative 27x? Hey, look, that's the same thing. Interesting. Let's do our subtraction. Negative 3x cubed minus 3x cubed is 0. We're happy. 2x squared is not having anything subtracted from it. It's just coming down for the ride. Minus 27x minus minus 27x is 0. So plus 0x. I'm just going to make it a happy face because it's funny. And now I have my 18 that I want to bring down. So I'll bring down my plus 18. and play the game one last time. X squared times what is 2x squared? Well, x squared times 2 is 2x squared. 2 times x squared is 2x squared. 2 times 9 is 18. And look, we're subtracting everything. 2x squared minus 2x squared is 0, which is happy. 0 is just 0, which is happy. And 18 minus 18 is 0, which is happy. So, dude, no remainder. That's sweet. That means that we've done our work correctly, and we found this polynomial. We have figured out what is left once we have factored out that x squared plus 9. It has not gone away. It still needs to be part of our final answer, but there it is. X squared minus 3x minus 2. Let's factor it, okay? So let's factor it as x, what is it going to be? Minus 2 times x minus 1. Because minus 2 minus 1 is negative 3, and minus 2 times negative 1 is a positive 2. So we factored it correctly, but we have not answered the question yet. The question said to find all of the real and imaginary zeros of the polynomial. Well, we started with the 2 imaginary zeros of the polynomial, and we just found the 2 real zeros of the polynomial. X minus 2 is giving us the 0 at x equals 2, and x minus 1 is giving a 0 at x equals 1. When I ask you to state all of the solutions, you have to tell me all of the solutions, including imaginary ones. If you don't tell me the imaginary ones, you're not telling me all of the solutions, and you will not get full credit. And when I say write the equation of the polynomial completely factored, if you just give me that, then you are so not correct. Completely factored will be y equals x minus 3i times x plus 3i times those other two factors we just found. But again, you have to include the imaginary ones, otherwise you are not doing it correctly. You may be doing all the individual pieces correctly, but you are not interpreting your final answer in the correct manner.